Today we're talking about mathematical induction. Now, we said mathematical induction is one of the techniques which can be used to prove variety of mathematical statements, theorem or formula that is asserted about every positive integer. Now, this means that when I'm dealing with mathematical induction, it is just that I want to be using it to prove formulas. I get what I'm saying now. So, steps involved in mathematical induction, or you can also call it principle of mathematical induction. So, for the principle, you say let P of n be given statement involving the natural number n such that 1. The statement is true for n equals to 1. That means if you are dealing with mathematical induction, the statement must be true for when n equals to 1. Then the second step is that you assume that the statement is true for n equals k. If it is true for that, you assume that also. Then the next thing is that you will now show that n equals k plus 1 is true whenever n equals to k is true. So this is where the work is. So let's look at some examples. Now look at this first example. It said prove that the sum of the first n natural number is given by the formula 2 into n minus 1 close bracket 2 close bracket equals to n squared. So let's do this first example before I come back to the second one. Have we got it now? So solution, you have 1 plus 3 plus 5 plus plus 2n minus 1 close bracket equals to n squared. Let me turn this over so we have something better to do. Are we enough? So now to do this, what do? You are only working with this and this. So you have 2n minus 1 equals to n squared. This is your left hand side, this is your right hand side. So when n equals to 1, now you are only to work with this side. You are just to check whether it is the same with this. So for the left hand side, we have what 2 into bracket 1 minus 1, which will give what 2 minus 1, and that will give what 1. Then for the right hand side, and we have what 1 square, which will give me what 1. So here 1 is equal to what 1. Therefore it is true, right? So you see what it is true. Say it's true for n equals what 1. I get what I'm saying now. So for n equals k, let me do that on this side. So you say when n equals k, you assume, assume, don't forget that's what they told us. You assume that it's true when n equals k. So that will now be what 2k minus what 1 for the left hand side, which will give me what k square. Are we following? So I will have k square here. This is what I'm using. 2n minus 1 equals to n square. So anywhere I see n now, I put k. I will get what I'm saying. So that's how I have 2k minus 1 equals to what k square. So now when n equals to what k plus 1, this is where the real work is now. When n equals to k plus 1, so you come to this place. So that will now be what 2. We have 2n minus 1. So if you put k here, that will be 2 open bracket k plus 1 minus 1, and that will give you what 2k plus what? 2 minus 1. Am I right? So that will now give us what? 2k plus 1. Abi? So I have this. Let me call this one. Okay. Now, when I get to this particular step, the next thing to do is that you now add k square to this side. You will do what? You add k square to this place. So add k square to equation 2. So let's call this one equation 1 and let's call this one equation 2. I got something, so I add this to this. So that will not give me what? 2k plus 1 plus what? K square. So rearranging it, we have what? K square plus 2k plus what? 1. I get what I'm saying. This has now become like a quadratic equation. So if you have to solve this quadratically, you will have what? K plus 1 plus k plus k square plus k plus k plus 1. Abi? So what's coming between this one? That's k, open bracket, k plus 1. What's coming between this one? Plus 1, open bracket, k plus 1. I'm sure you understand what I'm trying to do there. So you bring this together, that's k plus 1, k plus 1. Abi? So this one will give us what? K plus 1 squared. So if you open this k plus 1 squared, you will get something like this again. So this will be our final answer. So our final answer is what? K plus 1 squared. Now how will you check whether this is true? Don't forget that when I'm dealing with this part, I did not do for the left hand side. For the right hand side. This is just the left hand side. So now for the right hand side, if our right hand side is equal to this, then it is correct. Don't forget our right hand side is what? N squared. So if I'm putting k, if I'm putting k plus 1, that will now be what? K plus 1 all squared. So that means my answer is correct. Do you understand that now? So that is this for the first example. So let's look at the second example. I'll solve that on this particular side. So the second example, I have 1 plus 2 plus 3 plus, I have 1 plus 2 plus 3 plus dot plus n equals to n open bracket what? N plus 1 all over what? 2. Now this one too is very very simple. Let me divide this book into 2 so it will be much more easier. So don't forget you are only working with this and this. So that's n equals what? N plus n open bracket n plus 1 all over what? 2. So when n equals 1, so when n equals 1, you will have what on this side? On the left hand side, you will have what? 1, Abi? Then on the right hand side too, I must get 1. That was 1 open bracket 1 plus what? 1, Abi? All over what? 2. So that will give me what? 1 open bracket 2 all over what? 2. 2 cancel 2. That's 1, Abi? And that will be what? 1. So we can see that 1 is equal to what? 1, Abi? So you see it's what? It's true for n equals 1, Abi? So the next thing is you assume it's what? Is true for what? N equals what? K. So that will be what? On the left hand side, I will have what? K, Abi? Equals to what? What will I have here? K open bracket K plus 1 all over 2. So let's call this one equation 1. Abi? So when n equals K plus 1 now, let me work on the left hand side alone now. On the left hand side, I will have what? K plus what? 1, abi? No, I have only n here. So that will be K plus 1. So, like I did in the first example, you now add this equation 1. So let's call this one equation 2. So now you now have to add K open bracket K plus 1 all over 2 to equation 2. Now what's the equation 2? Equation 2 is what? K plus 1, abi? So plus K open bracket K plus 1 all over what? 2, abi? So that will now be what? K plus 1 plus, open this one will be what? K square plus what? K, abi? Over 2. So LCM will be what? 2, abi? Then 2 multiply this one will give us 2 into what? K plus 1. So this over 1. 1 into 2 is 2. To multiply by this, then plus what? This one will give us the same thing, that's K square plus K, abi? Then let's open this. This will give us what? K 2K plus 2 plus K square plus what? K all over what? 2. So adding this, I will have 3K square plus 3K plus 2, I mean, all over what? 2. Now, I can decide to call this my final answer, but let me try to expand more. Let me expand more on this. So, if I try to open this with quadratic equation, that will be what? K square plus 2K plus K plus 2, abi? So, all over 2. Now, what's common between this one? That's K, abi? Open bracket what? K plus 2, abi? K plus 2. Then what's common between this one? Plus 1. And that will what? K plus 2 also. I'm sure we are not new to this, so don't forget to also subscribe to the channel. Then this will now become what? K plus 1 K plus 2 all over what? 2. This will be my final answer when I did it for the left hand side. So how will I check whether I'm correct? Let me check for the right hand side now. So for the right hand side, that will be what? Don't forget we have n open bracket n plus 1. So that will be, when we are doing for K plus 1, that will be what? K plus 1, abi? Then put K plus 1 inside and again that will be K plus 1 plus 1. The one that is beside this, abi? All over what? 2. And that will give us what? K plus 1 K plus 2 all over what? 2. So you can see that my left hand side is equal to my what? Right hand side. So you now say it is true for all n. You get, that means it is true for all natural numbers. So this is where we'll stop for today. Don't forget to like and subscribe to the channel so you can get to see more videos as we upload. Thank you very much.